Now, today's topic is mini one mapping. A mapping F from A to B is said to be mini one if two or more elements of A corresponds to the same image in B through the mapping F. That means in your domain, two or more elements whose images are same in the codomain. Is it clear? Two or more elements of A means the domain whose images are same in the codomain. Sure. That means clearly note, clearly for many one mapping, range is a subset of codomain. See this figure. Domain is your 1 minus 1 2 minus 2. Codomain 1 4 9 16. Look at that. 2 maps 4. Minus 2 maps to 4. 2 maps to 4. Minus 1 maps to 1. 1 plus 1 maps to 1. That means here two elements whose images are same. Here also the two elements minus 1 1 whose images are the same, that is 1. Sure. So now for example, let A equals to minus 1 2 minus 1 1, B equal to 1 4 9 16, and if from A to B be given by fx equal to x square, show that f is a many one mapping. How to show it? Since fx equals to x square, so f of minus 1 equal to 4, f of 2 equal to 4, f of minus f of minus 2 equal to 4, f of 2 equals to 4, f of minus 1 equal to 1, f of plus 1 equal to 1. So we note that the elements minus 2 comma 2 of A have the same image 4 in B. Similarly, the elements minus 1 and 1 of A have the same image 1 in B. Thus, range of F equal to 4 comma 1, which is a proper subset of B equal to codomain. Sure. That means in your question, in your definition, if range is a proper subset of the codomain, then the mapping is called many one mapping. Is it absolutely clear? So now, into mapping. A mapping F from A to B is called an into mapping if there exists at least one element in B which has no pre-image in A. This is this example. The element 9, this element has no pre-image in the domain. Okay, and this element also 16, this element has no pre-image in the domain. Sure. That means this mapping is also called an into mapping. Sure. That means at least one. That means at least one element in B which has no pre-image in A. Sure. So now exercise. This exercise is related to injective, surjective and bijective function. Exercise 1.2. Is the relation f defined by fx equal to x squared 0 less or equal to x less or equal to 3, 2x 3 less or equal to x less or equal to 5 a function? Justify your answer. Next problem. A function f is defined by fx equal to 2x square plus 3 for all x belong to R. Find the image of minus 1 under f. Element or elements of domain which has image 35. Show that the function f from R to R defined by fx equal to 2x plus 1 for all x belongs to R is injective. Number 4. Show that the function f from R to R defined by fx equal to cos x is neither 1 to 1 nor on 2. Show that the modulus function f from R to R given by fx equal to mod x is neither 1 to 1 nor on 2. Next problem number 6. If the function f from I to I means here z, that means set of all integers, is defined by fx equal to 2x plus 1 for all if x is odd, 2x minus 1 if x is even. Find f3, f4 if number 3. Question number 3, part 3 is find x if fx equal to minus 9. Problem number 7, prove that the function f from R to R defined by fx equal to x cube plus 3x is bijective. Next question, show that the mapping f from n to n defined by fx equal to 3x is 1 to 1 but not on 2. Show that the function f from n to n defined by fx equal to 2x minus 1 is not on 2. Now, problem number 10 is prove that the mapping f from n to n defined by fx equals to x plus 1 if x is odd, x minus 1 if x is even, is bijective? Number 11, is the function f from n to n defined by fx equals to x square plus x plus 2 injective? Justify your answer. Thank you so much.